Hello, welcome to the first lecture for representing data. In this lecture, we will cover two learning outcomes, explain the mathematical modelling process, and describe reasons for carrying out mathematical modelling. So first of all, what is a mathematical model? A mathematical model is when we describe a real-life situation or problem in terms of mathematical equations. So for example, a real-life question is the annual population of wild horses in Kazakhstan decreasing? And this would be useful for us to know. We can create a mathematical equation for this. For example, the population at the end of the year equals the population at the beginning of the year plus number of births minus number of deaths. And this is called the mathematical model. As you can see, the equation is quite a simple one. And this is usual. A mathematical model is usually a simplification of a real-life situation. But this means we must always consider the accuracy of the model and how we can improve it. So how do we do this? Well, we can start by using this model to make predictions. In other words, try data and see what the population would be. And then compare our predictions with either existing data from the past, if it's available, or with newly collected data. If the predicted data and the actual data are a close match, then our model is an accurate one. However, if they are not a close match, then this means we may need to change our model. By considering other factors which may affect the real-life situation, we can change our model to improve its accuracy. So, for example, we may wish to consider the weather. If it's a particularly cold winter, we may have more deaths than usual. We may also wish to consider the food and water supply. This could affect the population of horses, as could the population of predators. Sorry, I shall correct my spelling. Predators, since they will obviously affect the population of horses. Why do we bother with mathematical models at all? Why are they useful? Well, as we have just seen, they can be used to make predictions about what would happen if something changed. They are very quick and easy to produce, and they simplify more complicated situations. And this makes them easier to understand the real-life problem. However, we do need to treat mathematical models with some caution. As we've said, they are a simplification. That means not all aspects of the problem are included. We have to be careful that we do not leave out very important factors. Also, the model may only work in particular situations. So in summary, there are 7 steps to the process of mathematical modelling. The first step is to consider a real-life problem. And the second step is to then create a mathematical model, develop equations to represent that real-life problem. Number 3, we then use these equations to predict what might happen, and we collect some real data, some experimental data, and we compare the predictions with the actual observed outcomes. And when we compare the two, there are statistical tests that can be done to tell us how accurate the results are. The numbers may be close, but are they close enough? But on this course, we do not have to know the actual statistical tests. Once we have decided whether our model is accurate enough, then we can make changes to that model if we need to make it more accurate. Now, in real life, what often happens is that steps number 2, 3, 5, 6 and 7 are often repeated several times. We keep modifying and improving our model the more information we have. So I hope you have enjoyed this first lecture, and now try the question.